The next thing to talk about with binomial distributions is how to use your calculator to kind of simplify this process a little bit. It's still going to be really important that you understand the formula and how it works, and I'll show you examples of both multiple choice and written problems on the AP test where you'll need to know the formula, but certainly if there's a multiple choice problem that's just asking you to do a calculation, then your calculator can speed that up. So we're going to be looking for this function right here, the binomial PDF function. You'll see that we still have this n parameter in here for our number of observations, p for the probability of success, and we've already defined k to be the number of successes that we're interested in. You find this function on your calculator under the distribution button, which is really the second function over vars near the arrows on your calculator. And then you need to scroll all the way down past function 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 to function A. At least that's where most of it will be. So you do have to do a little bit of scrolling there to get to it. So let's look at this first example. Suppose that the probability of a child having at least one parent with a college degree is 0.6. So that's going to be our probability of success. 0.6, and x, our variable, is going to represent the number of children with at least one parent of a college degree. So there's really your step one in this process. We're going to take a simple random sample of 6 children. So that's our fixed number of observations. So in our binomial distribution, we have 6 children. We have a probability of success of 0.6. We want the probability that exactly half of the children have at least one parent with a college degree. So half of the 6 would be 3. So here's step 3, your probability statement. Those are still going to remain the same for every problem. Now, instead of doing this process over here, where we do 6, choose 3, take our probability of success to the third power, the probability of failure to however many observations are left, we can just find that function in our calculator. We're going to type in the parameters n for our number of our number of observations, p is our probability of success, and then k, in this case we're looking for 3 kids. Type that in with the commas, hit enter, you're going to get this answer, and that will be the same thing as if you used the strategy that we learned last time with the formula itself. And what I did at the bottom of the page here is I just went ahead and in the calculator I found the probability that x equals each of the different numbers that k could take on. So it could be any of the countable numbers from 0 to 6. So lots of calculator work here, and then you'll see that the next row got copied on the next page, so I just added the cumulative distribution here. And then I did recopy the table on the next page as well because I'm going to refer to it when we do the binomial CDF function. So again, what I did here is this binomial PDF. In this case, I did 6, 0.6, 0, and you'll get this very small probability. Here, the last number changed to a 1. You'll see that this number is the same as what we calculated in this example, and so forth and so on. Go ahead and turn the page. Like I said, at the top of page 7 here, I recopied the table just so that I can refer to it as I work through these examples. When you saw the binomial PDF function in your calculator, I'm hoping you saw the CDF right below it. And this is going to, the C stands for the cumulative function, so it's going to allow us, as it says here in your notes, to find the, or answer the questions about at least, or fewer, or more, at most, without having to sum up so many probabilities. What it's going to do is find the probability of k and each value from 0 to k. So it's including the k value. Again, the C stands for cumulative. So let's just dive into some examples here. In example 1, it says, using this distribution, we're going to find the probability that 4 or fewer kids, 4 or fewer, have at least one parent with a college degree. So that means we're going to include 4 in our statement. I still want you to write this probability statement here. So this 4 or fewer, including 4, that means we're going to have the probability that x is less than or equal to 4. We're going to use the binomial CDF of 6, comma, 0.6, comma, 4, because we want everything from 0 to 4, including 4, and we'll get this probability of 0.7667. Check and see that that would be the same with some potential round-off error as if we were to go up to our table, find the individual values for 0, 1, 2, 3, and 4, and add those together. Why do more work when you have to if this CDF function is available to you? In example 2, you've got to make sure you read these problems really carefully. This wants fewer than 3. It does not say fewer than or equal to. It does not say 3 or fewer like the one above it did in our first example. It says fewer than 3, so we do not want to include 3 in our calculation. So our probability statement will start like this: the probability that x is strictly less than 3, and I need you to understand that that's the same as x is less than or equal to 2 because we're talking about the discrete case here. Fewer than 3 is less than or equal to 2. So what you'll type into your calculator for the binomial CDF is 6, comma, 0.6, comma, 2, and you'll get your almost 18% here in the end. As always, for each of these problems, you should be writing full statements in the end in order to have a complete answer if this were a written problem. Again, like the last one, if we were to go back up to the table, less than or equal to 2 or fewer than 3, that would be adding up the probability for 0, 1, and 2. You can see that that 0.1792 is what we get if we were to fill out the cumulative section of this table, which you won't normally have to do. That's why we have these functions available. There are a couple more problems to look at just because we can have some probabilities where we need to do some subtracting. Similar to table A, when we have z-scores and standardized values, we might want the area above a certain number, whereas the CDF function only goes below. So in example 3, we want the probability that at least 4 kids have at least one parent that has a college degree. So I know that in my statement, I'm going to at least start to think about it as the probability of x is greater than or equal to 4. At least 4 means I would include 4. If it helps and you don't already have the distribution written out, what the numbers can take on, we know we can go from 0 to 6. And so I'm going to look and circle the ones that qualify for this statement, at least 4. So that would be 4, 5, and 6 are the ones that I'm looking for. That means if I take 1 minus the probability that x is less than or equal to 3, that will give me the same answer. The cumulative function can't do anything, or it will always go from 0 up to a number. So it can't just do 4, 5, and 6 like we want it to. So you need to do a bit of a manipulation. So we're going to do the opposite or the complement of everything from 0 to 3. So that's what I have written here. This is the number that you should get out if you check on the table above. It is the same as what you get if you take the probability of x equal to 4 plus x equal to 5 plus x equal to 6. And up until today, like on your homework over the weekend, that's potentially what you would have done for this problem. So you still have that option, but obviously that's going to take a little bit longer. Really important that you understand what this number should be. These inequalities can get a little tricky, as you saw in example 2 as well, making sure you know what you want that k number to be, and then whether or not you want to subtract that from 1. The last example here, we want 1 or more kids, so that's at least one of the kids to have at least one parent with a college degree. So that's the probability that x is greater than or equal to 1. As we've discussed, this is the probability, or 1 minus the probability of none, or x equal to 0. When we find this x equal to 0, 0 is a special case. We actually could use the PDF or the CDF, since the CDF function goes from 0 up to the k value. 0 to 0 would be the same thing as just the PDF of 0. So just something to point out there, and you should get a pretty high percentage for that one. So hopefully those calculator strategies will help you zip through some problems a little bit more quickly. If you are going to use the calculator, I do expect to see this work in your homework. So I still want to see the probability statements, and then I want to see what you typed in and your final answer and your statement, of course, as well. If this were a written problem on the AP test, you really want to try to show that you understand the formula and how that works as well. I'll show you where it is on your green sheet on your formula card when I return. So happy calculating!